Welcome back, everyone. I'm Chris Warren with HVAC Pro Blog, and this month I'm excited to share a training that I provided 1 year ago for my Patreon members. It's ACCA Standard 12, Home Evaluation, and Performance Improvement. There are 4 key points that we cover after purpose and scope of this standard, and what we dig into is the basic interview that you conduct in the home, carbon monoxide testing, combustion appliance zone testing, and building envelope depressurization. So without further ado, let's roll the training. So just to give you an idea, the scope is really for 1 and 2 family or townhomes. It's for individual units when you talk about a multifamily and how to walk through what they consider the minimum criteria, right? So the purpose is to provide the information needed in order to do an audit, all right, an energy audit. It's going to establish how to assess opportunities, what the scope of work actually is, and provide industry recommended procedures to actually walk through those improvements. And then, of course, how to measure if your objectives are met, right? So not only are we making recommendations for the home, which the HVAC is included in this, but we're also seeing if we meet the standard that we set, right? So it's a full scope, okay? So in order to actually walk through a comprehensive performance audit, there's 5 major pieces to this. And I'm just going to cover these first pieces because I think this is the major side of it for an HVAC contractor to really grasp in order to do this correctly. And there's a lot of other aspects that go into the full audit. And I'll just cover those of what's in the standard and what's in the resource I'm going to show you. So first off, basic interview, and I'll walk through some of the typical questions that need to be asked in a basic interview when you do an energy audit. Also, carbon monoxide testing. This is very near and dear to my heart. I'm not sure if you know, when I was younger, I had a friend. My friend, his grandfathers actually passed away from carbon monoxide poisoning. They both lived in the same house. One had Alzheimer's. Pulled the car into the garage one night, left it running, and unfortunately passed away. Both of them. So it was very, very hard on him. Just hearing the story was tough on me back then. This was before high school. So, I really, when it comes to carbon monoxide, when I was a technician, I was walking in with a personal carbon monoxide detector on me at all times. More than once it's beeped and maybe saved our lives. So highly recommend you at least do carbon monoxide testing for obvious reasons here if you're not doing a full energy audit. I'll talk really quickly about what to look for and what to do for gas and oil leakage. And then we'll talk about combustion appliance zone testing. This is a very broad overview. I'm not going to walk through an example, but really I want you to know that if you're changing the performance of the house by installing or replacing an HVAC system, you've got to do a combustion appliance zone test if there is a combustion appliance zone. And then we'll talk about the envelope of the house and how that's tested. So really 5 or 6 basic things here in order to give you an overview of the standard and why it's important and why you should consider implementing this in your business, all right? So basic interview questions. You're going to find this is very similar to what a good salesperson does on a sales call in a residential HVAC business. So the first section of basic interview questions is really data collection. So you need to know, is this person you're talking to own or rent the building? How many people live here and how old is the building, okay? Do they plan to stay and how long have they lived there, right? So if they're not planning to stay for a long period of time, it's really hard to justify significant improvement to the building when you talk about payback. You got to talk about comfort in that instance, right? So really important to set the standard as to what you're going to be selling to here. Obviously, when you're collecting this data, you want to know if there was any major improvements already made to the home. And if you have a set of building plans, maybe some ad hoc drawings or something. I personally tried to be prepared by pulling the map off the data assessor's website for the town prior to a sales call. I think that's just great standard practice, and you don't have to necessarily ask for plans if you're doing a block load or something. Then you'll notice we're going to talk about utilities. We're going to talk about utility specific stuff further down the line, but are your utility bills high? All right, because if they are, then that means there's improvement to be made. If they have really low utility bills, it's going to be really hard to save them money, right? You can't save money that's not spent. So do you have the last 12 months of your utility bills? This is really important to establish how much savings could be had and where to address it. Is it going to be on your baseline, like lighting and appliances, or is it going to be the HVAC system, which could easily be half of your energy use in the house? And then, do you currently have any condensation problems in the home? This sounds elementary, but really important you want to address, whether it's ventilation or air sealing or just basic bulk water problems outside the house, okay? Then you're going to get into some questions about comfort, and this is where the HVAC guys typically excel, but if you don't, these are some things you want to make sure you ask. Do you have any hot or cold rooms in your house? So those of you that know me during my day job, we do a great job educating our contractors on hot and cold spot solutions. So hot and cold rooms are really important to address, because if you're going to fix somebody's system and give them a more efficient unit, you need to make sure you address the comfort problems, or it's going to make that worse, okay? Do you have any drafts in the house? Is there big temperature swings or noise? And if they say yes, you want to know where, and what do you do to combat it, right? Do you turn the thermostat up? Do you run the fan all the time? Because that's going to explain some of the energy use and some areas where you can save some energy, okay? And then, of course, any chance you open your windows instead of using air conditioning, and how often do you do this? What's the temperature outside usually? What if it's humid, right? So some of these questions you need to ask to establish some opportunities in order to provide solutions for the home, all right? Any IAQ problems? Is there a lot of dust in the house? Do you find yourself cleaning in this older home that's really drafty, right? Do you have any allergies or asthma or maybe health-related requirements? Any odd odors or smells? You'd be surprised what we find out there. No lie, one time I was on a call with a contractor, couldn't figure out an odor and a smell. We went into the attic, and sure enough, there was a trapped animal up there. So it's amazing what you find if you ask, okay? When was the last time you changed your filter? And I put LOL for a reason, right? So they'll tell you last week, but you gotta see that filter to be sure. If they haven't changed their filter in a long time, maybe it's not accessible, or they didn't know there was a filter, and that causes other household problems. Have you had maintenance on your systems? And this isn't just your HVAC system. This could be your water heater or boiler or whatever else that's in there, right? And then, do you have a programmable thermostat? And I'm going to always stick in, do you know how to use it? All right, so if we put one in, is that customer going to be able to actually use the programmable thermostat? Really, really important. Set that standard up front in your discovery or basic interview questions. Third section really focuses on the utility related stuff in home systems. I would say, do you currently use LED light bulbs? So I'd say the number one thing you can see in this picture here, can lights, great suspect for non-LED light bulbs. You can literally put your hand up to it and feel if it's an LED light bulb or not. They can use a ton of energy and throw off a lot of heat and create uncomfortable spaces in that instance. Kitchen exhaust fan, is there one equipped, and do you use it, right? What's the volume of air? You can see that one of the pictures, probably one of those 400 CFM or more kitchen exhaust fans that probably should be in a restaurant, not a house. But that's going to depressurize the space, bring in a lot of moist air in the summertime from outside. Where's the makeup air? Do you run it? Is it integrated in order to meet code, right? So all these things need to be asked. Bath exhaust fans. If you didn't know, you should be running a bath exhaust fan for at least 30 minutes once you complete a shower. Same thing with your kitchen exhaust. You should be running that to exhaust all that moisture that's in the space. Do you have a heated swimming pool? That's going to use a mess load of energy. Do you have an indoor swimming pool? Yes, there are some houses out there that have them. How are we going to address moisture? And obviously this standard does not address that sort of commercial situation where you have an indoor swimming pool, but you need to make sure that you address this, or at least bring it up like, hey, I can save you all this money, but your bill's still going to be through the roof because you're using electricity to heat up your jacuzzi out there, or whatever it is, all right? Then, of course, combustion safety is the fourth portion. I would first start off, do you have any wood-burning stove or fireplace? It's really important you establish that. You're going to need to know where these are when you start to look at the envelope. Do you have any unvented space heaters? It's not big up here in the Northeast. There's really some really good codes, but if you get into the deep parts of New Hampshire or Maine, or even down in Virginia, West Virginia, there's some unvented space heaters that heat houses down there. You don't want to tighten up the house if you have unvented space heaters, obviously. It could create some serious problems, and why we do carbon monoxide and CAS testing afterwards. So really important you establish the baseline and what you have today. Big note: carbon monoxide detectors, if they're more than 5 years, more than 5 years old, you should consider replacement. The new ones have better sensors that last longer. Okay, so take a look at those if you're in there doing an energy audit, or even if you're just doing a maintenance on the boiler or a furnace. Ask to see the CO detectors and check the date on the bottom. Take it off the ceiling or the wall and look at the date on it and make sure if it's more than 5 years old, either you provide a solution or recommend a solution. All right. So, CO testing requirements. In order to do carbon monoxide testing, you actually have to have a really good meter. You can't use the old Fire-Right gauge sets, right? So, hopefully most of you guys know what I'm talking about here, but starting to date myself. This is one of my older meters, probably 6, 7, 8 years old. But it needs to read carbon monoxide of a range from 0 to at least 2,000 parts per million, and it needs to be a resolution of 1 part per million. So you can't have a meter that just jumps around by hundreds or anything like that, because it won't tell you what you need to know. The accuracy on your meter needs to be at least plus or minus 5%, and you need to prove, if you're going to follow this standard, that it's calibrated annually by the manufacturer. Typically, most carbon monoxide detectors, if you go more than a year or two, the sensor fails and you have to send it out for calibration and sensor replacement anyway. But you need to carry documentation for the meter to meet this standard, that it's been calibrated within the last calendar year. All right, the reason for this and what you need to do first is turn on your meter outside. I know this is going to sound crazy to most of you guys, but there is a baseline carbon monoxide, and it depends on where you live. I'm going to be honest, these days, because of COVID and lack of transportation, I'm willing to bet the carbon monoxide baseline's lower in most cities than it usually is. But baselines could be as high as 10, 15 parts per million, believe it or not. So you're basically zeroing your meter based on what the conditions are outside, okay? Then you're going to actually, during a depressurization test, I'll talk about that in a minute here, test atmospheric appliance first. So typically you'll find atmospheric appliances are ones with standing pilots, typically hot water heaters or older boilers, steam boilers, and then stoves, right? So atmospheric appliances first during depressurization. Then you're going to test vented appliances, and unfortunately vented appliances could be like a 90% furnace, something along those lines, or a boiler. You have to measure that at the outlet of the boiler, not outside where it's going to give you a mixture of fresh air and stuff. So you have to actually probably drill a test hole if there's not one there already. A lot of boilers are great, they give you that connector with the test hole already. But that can be worrisome. Make sure you have a cap and some sealant in order to seal it up if you have to drill one, okay? And then, of course, you're going to test unvented appliances last, okay? All of this is done during the depressurization of the home. Then, obviously, you would look at gas ovens. I apologize, I skipped forward there. Gas ovens would be after unvented appliances. And then you want to verify your threshold limits are within the air-free measurements allowed by the National Fuel Gas Code. In the NFGC, it's table G6. It establishes what the maximum CO is on the air-free measurement, all right? So there is some math to take out the air. Carbon monoxide air-free is typically a little higher, all right? So you want to make sure you do the math to find out what the air-free is and compare to table G6 to make sure that that appliance is within operable limits. If they're higher, typically you have the incorrect air and gas mixture, right? And you probably need to maintain that unit or replace that unit if it's dangerously high. I've seen CO readings in 300 to 400 parts per million, maintained a boiler by sucking all the soot out of it, reconnected it, and it's down below 50. So sometimes it's just merely maintenance. Doesn't mean you have to replace the unit. Don't scare the customer, but you do have to shut it down if it's high, okay? So really important you test that. Now, once you do that, you're also going to want to make sure you take a look at the gas and oil line leakage. Make sure that you do a tightness and proper installation check. So that means hangers, that means you're going to use a gas leak detector or soap and bubbles, soap leak tests, something that you can measure down to a really low pressure with. Obviously oil lines, you're going to look for visual signs of leakage, and if there is any leakage anywhere, you're going to want to mark those locations, and if you're not a serviceable company that can handle that for licensing purposes, you're going to want to make sure you recommend somebody that can come out and service that. So if you don't do oil, make sure you have a connection here if you're going to an oil heated home, all right? Sometimes oil delivery companies do service. A lot of times, I'm in Massachusetts, it's about 50-50. A lot of guys just deliver oil and they don't do service. So really important, you have a connection there. And then of course, if it's prior to the regulator, you should probably call a gas company if it's a natural gas line. So really, really important, you have a connection there and know the 800 number to call. I actually had that at my own house not too long ago. All right. Luckily, it didn't explode, right? It's been here 140 years. It's not going anywhere. Depressurization testing. So combustion appliance zone testing. This is really important. If you replace a duct system, you put a new HVAC system in, you seal a duct system, or change the building performance in any way, you need to make sure you do a CAS test. You don't want to hurt somebody or their family because you improved the comfort of their house. It makes no sense. In order to help everybody sleep at night, you need to learn how to do this testing, and you probably need a blower door to do it, okay? Or bring in an energy auditor to do it for you, okay? So in order to do this, there is a process here. You have to go in order. You want to close exterior windows and doors and put them in what is considered winter condition. So lock the windows, close the doors all the way, maybe a deadbolt to make sure it's tight, all right? Make sure all the drain traps in the house are filled with water. This sounds elementary. I've seen situations where people don't use showers very rarely on one floor of their home, and the trap is dry, and we're getting leakage and we're pulling sewage gas back when we start to depressurize a house. So really important, go and check and run all of those drains and make sure that the trap is full. Obviously on a new construction home, that means you have to have water there, or you're going to be dumping water into all these drains in order to make sure they're full. Make sure all the indoor exhaust fans are on except for any whole house fans. So the kitchen vents, the bathroom vents, any sort of ERV, that sort of thing, okay? Turn on the air handler and then measure the combustion appliance zone differential. So obviously you're going to be down where these combustion appliance zones are. So you're not going to be measuring this stuff in the bedrooms. You're going to be measuring it in the basement where the boiler is, or on the first floor closet where the water heater is, or whatever it is, okay? If there's no differential with the air handler on, if it's the same, then you can shut the air handler off. That means the ductwork's probably really well sealed, okay? If it's not well sealed, it's really easy to pull air through the return, let's say in a basement furnace, and then the water heater's running, and the air's got to come from somewhere, okay? So that would lead to saying, okay, I need to seal up the ductwork if running that air handler creates a big differential. Then, of course, you're going to want to open and close the interior doors of the combustion appliance zone to get to worst case. So if you close a door or open a door and it makes the combustion appliance zone go more negative, you want to leave it in that position. You want worst case scenario here, okay? Then always make sure your makeup air is as is. Don't open makeup air vents or turn makeup air on. This is really important, like fans in a can for boilers, things like that. Don't turn it on during this test. Make sure your vent or your flue pipe is at room temperature when you do this test. Okay, really important when you start the test. And then, of course, you close any fireplace dampers. So any wood-burning fireplace dampers, close them off. You always want to test the smallest BTU per hour appliance first, and then make sure you're testing for spillage. That's the whole point of this here, okay? Some people do it with a mirror. A lot of people do it with carbon monoxide detector, okay? And if you have more appliances, you want to walk through steps 1 through 10 in the same order, and you repeat for each appliance that's within the combustion appliance zone, all right? Always getting to worst case scenario. Really, really important. We don't want to suck up a bunch of flue gas and evenly distribute that around the house through that furnace or air handler that's in the basement or whatever the situation. I've also seen depressurization of hallways when you have a central return, let's say in the hallway of a second floor, and you have a wood-burning fireplace in the living room, all right? Somebody kicks the fan on to distribute the heat, right? It's really distributing carbon monoxide in that instance, and that's why we test carbon monoxide detectors. Okay, so I don't want to be the bearer of bad news right before Christmas here. So envelope testing. So this is one that is hard to convince HVAC contractors they should be doing. To really get the true heat loss of a house, I'm going to be honest, you have to test the envelope, and most people don't do this. Most people take an educated guess. If you've walked through some of my system design training, I give you what the educated guess should be based on the age of the home and what you see for air sealing and stuff like that. If you measured the air changes per hour at 50 pascals, you would know what the air changes are. You could say it's tight, semi-tight, loose, whatever it is in that load calculation and get the real heat loss of the home. All right, so before you do this testing, always safety first. You have to do an inspection to see if there's any asbestos in the house. I don't care if the homeowner says, yes, they removed it all. Go and check. When I bought my house, 1880 Victorian, I had asbestos removed from the whole home. Lo and behold, before we did a envelope test with the energy auditor out here after I bought it, he found some, okay? Even if it's been done by an expert, sometimes they miss something, okay? So do a visual inspection of all where you think asbestos could be, okay? Then you want to set up that blower door in the main door of the home. You can see that picture on the right-hand side of the slide here. You're going to depressurize the house to negative 50 pascals, okay? So a 50 pascal difference between inside and outside. If you have a two-family home, you have to do this simultaneously, so there's no pressure difference across walls. Otherwise, you could really influence the leakage. It looks like it's a lot when you're really just pulling from another space, okay? So once you get that, you find out what the opportunity is. Of course, you don't want to seal the house too much. Then you have to start adding mechanical ventilation unless you actually want to do that. Some people want it as tight as possible for obvious reasons, but then you need to make sure you can provide fresh air. All of that standard is within standard 12 or ASHRAE 62, right? 62.2. You can look there as well for that. But this establishes really the basics of what you need to be doing when you look at the house as a system. And ACCA did a great job developing the standard, and it's starting to really get noticed by ResNet and other folks in the industry, and really driving the whole home approach. So other parts of this standard that I didn't really dive into deeply, things like ventilation, like we just talked about, but in much more depth. How to identify insulation and what it should be for the home. Obviously a broad overview of heating and cooling systems for those that may not be familiar with it. If you're watching this, I'm sure you are. Water heaters and how to address that issue. Appliances, equipment in the home. How to deal with moisture and what happens if you have a pool or a spa in the house. And then of course cost-benefit analysis, how to document all of this, and what to do if you have unsafe conditions. So that's really what the standard addresses. What I would say is if you want to implement this into your business and you're not sure where to start, I think the best thing to do would be to obviously download the free ACCA 12 standard. That's free, all right? The most recent, I believe, is 2015. And then, of course, take a look at the Technician's Guide and Workbook. Like most of their standards, after they release a standard and it becomes code, then they actually release a guide to go along with standards. So it's not enough to say, as an example, Manual J is code. Well, there's a Manual J explained and how to apply it too, right? So the same thing for this, Technician's Guide and Workbook for Home Evaluations and Performance Improvement, all right? In this, they talk about how to implement ACCA Standard 12, what measurements you have to take and tools you need, and what documentation, and they give you some basic templates for this. It's $90 on the ACCA site. I highly recommend it. I have a copy right here myself, and you know, granted, I am a little bit of a nerd and I am a technician in the past, so it seems like good reading to me. Probably not something you want to read in bed, because it probably would put you to sleep unless you're doing this every day. So, what did you think? Did you like the training on ACCA Standard 12? Was there any details that you thought I should have gone deeper into? I'd love to hear it in the comments. If you found value in this video, be sure to subscribe so you always see the new content that we aim for to deliver weekly. If you'd like to get this training, among many others, 1 year in advance with my Patreon members, just head over to that page. You can join for as little as $8 a month. Of course, I want to say thanks for joining me at HVAC Pro Blog, where we provide advice for residential system design, quality installation, and system diagnosis. I'll see you soon.